Now, in order to monitor what type of traffic is on your network, you need a mechanism to capture packets from network traffic for analysis and potential logging. Packet sniffing, or packet capture, is the process of intercepting network packets in their entirety for analysis. It's an invaluable tool for IT support specialists to troubleshoot issues. There are lots of tools that make this really easy to do. Before we dive into the details of how to use them, let's cover some basic concepts of packet sniffing. By default, network interfaces and the networking software stack on an OS are going to behave like a well-mannered interface. It'll only be accepting and processing packets that are addressed to its specific interface address, usually identified by a MAC address. If a packet with a different destination address is encountered, the interface will just drop the packet. But if we wanted to capture all packets that an interface is able to see, like when we're monitoring all network traffic on a network segment, this behavior would be a pain for us. To override this, we can place the interface into what's called promiscuous mode. This is a special mode for Ethernet network interfaces that basically says, give me all the packets. Instead of only accepting and handling packets destined for its address, it'll now accept and process any packet that it sees. This is much more useful for network analysis or monitoring purposes. I should also call out that admin or root privileges are needed to place an interface into promiscuous mode and to begin to capture packets. Details for various platforms on how to get into promiscuous mode can be found in the supplemental reading section. Many packet capture tools will handle this for you, too. Another super important thing to consider when you perform packet captures is whether you have access to the traffic you'd like to capture and monitor. Let's say you wanted to analyze all traffic between hosts connected to a switch, and your machine is also connected to a port on this switch. What traffic would you be able to see in this case? Because this is a switch, the only traffic you'd be able to capture would be traffic from your host or destined for your host. That's not very useful in letting you analyze other host traffic. If the packets aren't going to be sent to your interface in the first place, promiscuous mode won't help you see them. But if your machine was inserted between the uplink port of the switch and the uplink device further upstream, now you'd have access to all packets in and out of that local network segment. Enterprise managed switches usually have a feature called port mirroring, which helps with this type of scenario. Port mirroring allows the switch to take all packets from a specified port, port range, or the entire VLAN, and mirror the packets to a specified switch port. This lets you gain access to all packets passing on a switch in a more convenient and secure way. There's another handy, though less advanced way that you can get access to packets in a switched network environment. You can insert a hub into the topology with the device or devices you'd like to monitor traffic on connected to the hub and our monitoring machine. Hubs are a quick and dirty way of getting packets mirrored to your capture interface. They obviously have drawbacks though, like reduced throughput and the potential for introducing collisions. If you capture packets from a wireless network, the process is slightly different. Promiscuous mode applied to a wireless device would allow the wireless client to process and receive packets from the network it's associated with, destined for other clients. But if we wanted to capture and analyze all wireless traffic that we're able to receive in the immediate area, we can place our wireless interface into a mode called monitor mode. Monitor mode allows us to scan across channels to see all wireless traffic being sent by APs and clients. It doesn't matter what networks they're intended for, and it wouldn't require the client device to be associated or connected to any wireless network. To capture wireless traffic, all you need is an interface placed into monitor mode. Just like enabling promiscuous mode, this can be done with a simple command. But usually the tools used for wireless packet captures can handle the enabling and disabling of the mode for you. You need to be near enough to the AP and client to receive a signal, and then you can begin capturing traffic right out of the air. There are a number of open source wireless capture and monitoring utilities, like AirCrack-NG and Kismet. It's important to call out that if a wireless network is encrypted, you can still capture the packets, but you won't be able to decode the traffic payloads without knowing the password for the wireless network. So now we're able to get access to some traffic we'd like to monitor. So what do we do next? We need tools to help us actually do the capture and the analysis. We'll learn more about those in the next lesson.